Island is a sandboxing tool powered by Landlock, which was recently announced, and I decided to make a short video for curious beginners on what this tool actually does, and what Landlock is. So Landlock is a stackable LSM available in the kernel for quite a while. I'm going to be using kernel 617 from Debian Unstable, and its goal is to restrict the ambient writes of a process. There's some documentation here. We're going to walk through a few of this again, and I don't know the history behind Landlock, but I know that it used to be as a concept eBPF based, so some of it reminded me of the 2020 BPF box and later on the container box project, which wanted to use eBPF for process confinement. A couple things about BPF bugs that stand out is that not only it wanted to go through LSM hooks for requests and policy decisions, but that it would that the policy language would be granular enough to apply against specific functions inside the application, and that was again a little bit of the eBPF trick behind it. In terms of what it tried to sandbox, it included, of course, file system paths as well as network binding. So some ideas of that will come up later today. In the Landlock page, we have information about different integrations. You can use Landlock in your own application because a lot of what Landlock tries to do is for the children of a process to restrict themselves. So you can certainly do that through a library, but you can also use finished tools that already integrate Landlock. And that will include Island, which we're gonna talk through in just a second. You might see familiar tools here like FireJail and a few others. And one that I wanted to call out a little bit is setpriv. Setpriv is interesting in that it can run programs with different privileges using the different functionalities of the stackable LSMs available in the system. And that's unique in that Landlock itself really focuses on credentials, as you can see from the documentation. It deals with tasks credentials. And that's actually going to be one of the things I would like to explore a little bit more in the future, is how to explore that structure as you debug sandboxed applications. To that extent, the credentials in Linux section of the kernel docs could be useful for those of us that are interested in learning a little bit more about this part. One of the integrations called out in the Landlock side is Pledge, or Pledge for Linux more precisely, and there is code for that, but I like the blog post that talks a little bit about Pledge for Linux and how it kind of came to be, the implementation wise and whatnot. But the promises, again, going back to what can you actually prevent an application from doing with Sandbox, it does talk about things like standard I/O and read and write paths and network sockets for binding and things like exec and whatnot. And again, these are implemented through Landlock. And you're going to get a sense of what you could do that in just a very simple demo we're going to do in a second. Earlier I talked about setpriv, and again, setpriv goes a little bit beyond in that you can use it to run a program, as you can see here, but you can limit the capabilities of that program. You can set the no new privs bid. You can set secure bids. You can also set the SE Linux label and or the AppArmor profile for the transition. And then for Landlocked, you can specify rules as well as kind of more coarser access groups. And of course, you can do seccomp filters as well. So as you can see, setpriv can do a lot of things. And internally, of course, the way that it implements the Landlock support is very similar to the sandbox sample code that's provided in the Landlock page that uses the Landlock restrict self syscall. We're going to be coming back to that in just a second. One more thing I wanted to mention is let's just switch over to the functional parts of Island, right? In the Island README, you get this nice TLDR, and essentially you're going to be moving to a path on disk and then creating a project. This will create config files in a well-known location in the file system. And then this will be the convention as you then want to constrain yourself for further operations. In this case, the example given is that you can list all the things that are below the path that you created your project on, but you cannot access things that are beyond the path that you're currently working on. And then there's a little trick here which you don't see, and we'll see in our demo, which is that um, this this um, the seashell hooks are used so that you can continue executing commands as usual, but those will actually be sandboxed. So this is implemented as a Rust project. There's a bunch of landlock crates used here, and we'll get to that in just a second. Now, if the whole concept of being able to sandbox operations that happen underneath a certain path sounds like it could be useful for systemd services, that's an actual proposal as well, is to be able to specify in a unit the landlock config, and then the policies would look actually very similar, if not the same, as the ones you're going to see for Island in just a moment. So let's switch over to the terminal now. I'm going to be focusing right now on just showing you how this operation works. I have a bunch of files in this path that I'm going to be allowed to run, and I have we can create just a file in temp just to give you an example of something that's outside of this path. Now I'm going to start running the following commands on the sandbox, and the clearest way to see it is when you run island run, and then we're going to try and look at a file that is on this path, and I'm going to be able to read it. And when I try to see one that is not in the path, I'm going to get permission that, even though I created it, right? Like this is well beyond the standard POSIX user and group access model. So again, when I created the profile for this path, special config files were created, and this basically describe the path beneath where all the policy will apply. And then of course there's a base one that's included that has all the specifics of it, and allows me to read and execute from binlib and USR, because of course I'm going to need to operate with binaries, and it allows me to read things from Etsy and that type of stuff, right? So now let's take a little bit of a deeper look, but still keeping it quite simple. By basically, I'm going to run Island in a debugger. And because I know that from the docs and from the sample code and from the Rust crates used by Island, I know that there's a syscall called landlock restrict self. I'm just going to set a breakpoint for that. So we'll do that. And I could also operate on a couple other syscalls or some functions, but I think this is just easy enough, and then we'll switch to a different instrumentation mode to look at it a little bit more deeply. So I'm going to go ahead and run basically the same command that I ran, the one that succeeds. And so the program starts, and I'm going to hit my breakpoint when I try to transition to landlock restrict self. And if I look at how I got here, I started in main, that's the entry point for Island, and I went over to run, and then I was around in the landlock crates, and eventually I'm jumping to the syscall, and I'm going to continue, and I'm coming back from that syscall, and then I'm going to continue, and now process is executing the new program, which is cat. That is the program I'm intended to sandbox, and then I see the output that's expected here. So that's a simple thing to look at with GDB. But I also have some BPF trace policies in order to be able to look more deeply at the things that are happening on the kernel side. And I'll explain one limitation that I have that I would like to explore in further deep dives. First, let's look at the policies that I have here. Basically, I'm setting a probe on exec, and I'm setting a probe on clone, and I'm setting a probe on process control, and on landlock restrict self, and I'm doing one for file open here, and it's important to call out that this is security file open. So this is a function that where LSMs can hook themselves into for file open operations. I also have commit creds, and I'm also looking at the return of security file open because I want to be able to show when those operations are blocked, and then open just because, of course, ultimately what matters is whether I can do my open, right? So I have those probes set up, and I'm going to run them here in this system. And here on the right, I'm just going to run my commands again. So first, I'm going to run the command that has access, the one that I'm supposed to have access. And we're going to scroll up to see what happened here. So first, the command that that I intend to run. There's a bunch of creds set up for that command. And the reality is here that the UIDs, the secure bits, the capabilities, the namespace, the key rings it has access to, none of that will change in the three that we're going to look at right now. The thing that really changes is the security object, but as I said, this is something that I had not been able with the tools that I have right now in the time that I allotted for this experiment to look a little bit more deeply on. So credentials are committed. Then there's a process control here to set no new privileges. So that happens, and that's part of Island. Well, we can see that in the code if you dig in the code. Then we enter landlock restrict self. New creds are created. So that's a critical part of our understanding here is that new creds are created for this process Island. And then I exit, I come back from the syscall. And then I try to exec cat, I look for it, and then finally when I find it, then I have the commit credentials for cat, and that's when I perform finally whatever work cat's trying to do. In this case, it's trying to open file foo.txt. So I wanted to dig a little bit more deeply, specifically into the fact that once you go into landlock restrict self, which is on kernel side, then new creds are created, and then you return with those creds, and then once you transition into cat, you are bound by those creds, right? Now let's start over and just do it with the process that you're not supposed to have access to. And so everything here is exactly the same. I got cred set up before I start working. I then set no new privs and then go into the syscall and then set new creds and then return from the syscall, and then I start looking for cat. But the thing that to call out here is that security file open came back deny while accessing foo.txt, and so there never was an open AT. Again, the interesting thing to dig a little bit more deeply on would be the security objects, which are all different in these three creds that are shown in this very simple example. And I really tried to do this with Tetragon because Tetragon does have a use case for Linux process credentials, and you can do it on user space, you can do it on the kernel side. But I think the problem here is that the process credentials struct that is used in Tetragon that has been there, I believe, since 2023, has things like secure bits and capabilities, but doesn't have the security object, which I believe is quite arbitrary depending on the stackable LSMs that are involved to set those creds. So that's an area I would like to dig a little bit more deeply. Hopefully this is useful for curious beginners that are interested in sandboxing and specifically on Landlock, and it can help as a way to start exploring some of these other integrations that are listed out here in the project. Thanks again for watching, and take care.